All right, today we're going to continue in section 4.5. Last class we looked at solving exponential equations. Today, log equations. Just like last time, we're going to have exact solutions in places. So we will have to look at what's going on with that and having two different answers. So just like last time when we were solving, we had to get the exponential by itself. If we have a log, we need to make sure that we can get the log part by itself. So you'll notice here that I have this 5 times. So when I'm multiplying, the first thing I need to do then is divide this by 5 so that we get the log part by itself. So then I have log base 10 of x minus 2 equals 11/5. So we always want to get the log part by itself. And then when you do that, also don't make this a decimal unless it works out perfect. If you round that at all, it will change your answer at the end. After we make this the log by itself, now we're going to rewrite it in exponential form. So in exponential form, it doesn't matter what's on which side on here, but 10 to the 11/5 equals x minus 2. So we have our exponential form. So to get our exact answer, we need to get the x by itself right here. So I add 2 to both sides. So x equals 10 to the 11/5 plus 2 would be our exact answer. Then you can plug that into your calculator. Plugging it into your calculator as your approximate answer, 160.489. So that would be solving our log equation. So looking at another one here, I have natural log of the square root of x minus 8 equals 5. There's a couple different ways you could work this one. So one on here when we're working this is to just go ahead and rewrite it in exponential form. The natural log part is already by itself, the ln. So when we do this, and when it's natural log, we use e. So this would be e to the 5th equals x minus 8, the square root of x minus 8. Now we need to solve for x. So to undo a square root, we're going to square both sides. So remember, when I have an exponent to an exponent, this would be e to the 10th equals x minus 8. So solving for x, I would get e to the 10th plus 8. So this right here is our exact answer. And then we need to plug that into our calculator to get our approximate answer. So if we plug that into our calculator, I have to do that real quick. I get 22,034.466 would be our approximate answer right here. So remember, on your homework, just like last class, you're going to have two different answers. Okay, so then did that differently when I did it here. Here we have another one. We have 2 minus 6 ln of x equals 10. Again, I have to get this ln of x by itself, so undo addition, subtraction first. So the first thing I would do is subtract the 2 from both sides. So if I subtract the 2 from both sides, I have negative 6 equals ln of x, negative 6 ln of x equals 8. Then we have multiplication right here, so we need to divide by negative 6. So ln of x equals negative 8 over 6. Reduce it to negative 4/3. Write it in exponential form right here. So e to the negative 4/3 x. This right here is fine as your exact answer. I will take this. A lot of times you'll see it written with a positive exponent, so you would see it written, as e1 over e to the 4/3, but you can leave it as a negative. I'm fine with that. Plugging it into your calculator for your approximate would be 0.264. Here, notice on all the ones before this, the log part was only written one time. Here it's written twice. So the first thing we have to do is condense this side into one log using our rules, our properties that we learned in section 4.4. So remember, when I'm adding right here, that means I multiply what's inside. So I would have log base 3, and all of this is multiplied together. This x times our x minus 8 equals 2. So we can go ahead and multiply that out. So I have log base 3 of x squared minus 8x. Now from here, we're going to rewrite it in exponential form again. So this would give me x squared minus 8x equals 3 squared. Of course, we know that 3 squared is 9, so you could go ahead and put a 9 there. Because it's a quadratic, I now need to put everything on one side and either factor or use the quadratic formula. So if I move over my 9, x squared minus 8x minus 9 equals 0. We could, again, you can factor, use the quadratic formula. This one factors easily. This one factors into x minus 9, x plus 1. Remember, then we set both those equal to 0. X minus 9 equals 0. X plus 1 equals 0. So I get two answers. I get x equals 9 and x equals negative 1. But when a log equation has a variable with a degree greater than 1, so ours was squared up here, you need to check for what we call extraneous solutions. So to do that, what we have to do is we have to plug these two answers back into our original equation up here and see if they work. Checking that is not something you need to show me on your homework, but you need to make sure you do it so that you get the right answer. So for example, if I want to check this, we substitute them back into our original. So I'm going to start with 9. So right here, I'm going to use x equals 9 and plug it back in. So I'd get log base 3 of 9 plus log base 3 of 9 minus 8 equals 2. Simplifying that, log base 3 of 9 is 2 plus log base 3 of 1 right here. Well, log base 3 of 1 is 0. So 2 equals 2, so that means x equals 9 is a good one to use. If I were to plug in -1, you see that I have log of -1 right here, and this would be log of -9. You cannot take the log of a negative number. That's not possible. So therefore, -1 is extraneous. So when you give me your answer, you would just say x equals 9, cross this one off, or do something like that. You don't have to tell me it's extraneous. Just knowing that it is works just fine. So if we look at another one of those, here I have ln of x plus 1 minus ln of x minus 2 equals ln of x. Again, over here, I need to put these two, combine them into one log. So remember, subtraction right here, when I put them together, means division. So I would have ln of x plus 1 over x minus 2 equals ln of x. Then also remember from our properties, if I have ln of something and ln of something, these ln's cancel. So I would just be left with x plus 1 over x minus 2 equals x. Now I need to solve this. What I would suggest doing is making this like x over 1 so that I have a fraction equals a fraction. And then you cross multiply. So you're going to have x plus 1, and then so you'd have x plus 1 equals, and then you multiply here x times our x minus 2. So you're just bringing it over. So x plus 1 equals x times x minus 2. We need to distribute to get rid of our parentheses. So x plus 1 equals x squared minus 2x. We need to get everything on the same side. So here I would subtract the x and the 1. So over here we would have 0, and then x squared minus 3x minus 1. So here I'm just moving over here to the other side. So I would have x squared minus 3x minus 1. Trying to get to my eraser here to erase this part so we can see everything again. So now I have this, but I can't factor that, so I have to use the quadratic formula. So if you've forgotten the quadratic formula, I put it on here for you. Plug in what our b, a, and c are, and then simplify, and we would get 3 plus or minus radical 13 over 2. So I actually have two answers right here. You actually have 3 plus radical 13 over 2 and 3 minus radical 13 over 2. So you have two different answers. We would need to check them to make sure that they are right. So again, remember this is 3 plus radical 13 over 2, and it's 3 minus radical 13 over 2. So just like we checked for extraneous solutions in the first one, I need to do the same thing here. So if we worked this out, and put like in a decimal, this is 3 point something, I can't remember exactly what it works out to be, and this is negative 0.3 something. So this is a negative number. Again, I can't plug that in, so this one wouldn't work. This is the only one that we would have. Oh, it's 3 point, there we go. It's 3.303. This one's negative 0.303, I believe, if you put it in your calculator. So you're going to throw out the negative because that's not in the domain of our natural log, and so we only have our one answer with the positive on this one. Okay, so then we have some applications. We only have one that we're really going to look at. So there are many real world ones. We're going to deal with our money, like investments that we are looking at in sections 1 and 2. So remember, we had two different equations. We were working on this. You invest $3,000 into a bank account with an interest rate of 6.85%, compounded monthly. How long will it be? How long will it take for your investment to double? So remember, we had two equations. We had A equals P e to the RT, and we had our A equals P times 1 plus R over N to the NT. So you have to decide which equation to use. We are going to use our A equals P 1 plus R over N to the NT, and then know where we're substituting things in. So you invest $3,000. So $3,000 is going to be our P. Into a banking account, this is our R, interest rate. Compounded monthly, that means that our N is 12. We want our investment to double. So if I want my 3,000 to double, that means my A right here would be 6,000. And how long will it take? We don't know T. That's what we're going to solve for. So if I plug in everything I know, we'll have an equation here. I just have it backwards from my A up here. 3,000 times 1 plus 0.0685. Remember, you have to change your rate to a decimal. And then we're going to solve this using the exponents, which is stuff that we did like last class. So the first thing you would need to do is divide this 3,000 on both sides to get the exponential part by itself. So divide the 3,000. So I get 2. Write this in log form. So log of 1 plus all of this of 2 equals 12t. Then remember here you would need to divide this by 12. So because it's a word problem, you don't need to give me an exact form. So you could just plug that into your calculator, divide by 12, and you should get approximately 10.15 years. So you're going to be in this time, last time we were looking for A or P when we were doing our investments. Now you're usually going to be solving for your T. So keep that in mind. There are 2 different equations. You could use that one, or remember, you might still have to use this one, which is our continuous one that we had from sections 4.1 and 4.2. So that is the end. If you have any questions, please let me know.